Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we have started the chapter Transaction Management. In Transaction Management, today we are going to discuss about concurrency control protocols. Let us start the session. What are concurrency control protocols, or what is the use of concurrency control protocols? These protocols are used to ensure that we generate the schedules which are equal to serial schedules. So that means they will give guarantee. The concurrency control protocols will give guarantee to produce the schedules which are equivalent to serial schedules. What does it mean, sir? Which are equal to serializable schedules. So when we follow concurrency control protocols, the resultant schedules always serializable. That is the meaning of this statement. So this is the main use of concurrency control protocols. What are the types of concurrency control based protocols? There are mainly two types, sir. The first one is lock based protocols. In lock based protocols, we are having so many variations. The first one is two-phase locking protocol. Under two-phase locking protocol, again we are having some variations. The first one is basic two-phase locking protocol. The next one, strict two-phase locking protocol. The third one, rigorous two-phase locking protocol. The fourth one, conservative two-phase locking protocol. So these are the variations of two-phase locking protocol. And there is one more locking based protocol, which is graph based protocol. The another type of variation uses timestamps. Instead of lock mechanism, the protocols will use timestamps. What are the variations of timestamp based protocols? The first one is timestamp ordering protocol, and the next one is Thomas Wright rule. So these are the different types of concurrency control protocols. In this session, we are going to discuss about lock based protocols or protocols based on locking mechanism. In next session, we will continue the remaining concurrency control protocols. So let us start lock based protocols. Lock based protocols. What is a lock? A lock is a mechanism to control concurrent access to a data item. Okay. In simple example, suppose I have a system and I want to use this. So let us assume the system is present in a room. The system is present in a room. I want to access this system. So what I do is, before I use the system, I will get a lock. I will get a lock so that I can enter into the room and I can use the system. Since I have a lock, I will lock here so that no other person will enter into the room and use the system. So it is mainly used to control the concurrent access to the system. Instead of system, let us suppose it is data item. So whenever a transaction wants to access a data item, to access it, first of all, it need to get a lock. Then it need to work on it. After completion of your work, release your lock or hand over the lock to the management. So release your lock because you completed your work, right? This is called locking mechanism. data item can be locked in two ways. The first one, exclusive lock. Exclusive, sir, I think it's not executive, sir. Sorry, exclusive lock. Exclusive. So the lock is exclusively for you. So there is only one lock that is also with you. So when you have that exclusive lock, no other person is allowed to enter into the room. That is something like a single private room. So no other person will enter into your room, or no need to suppose to share the room with anyone. That is exclusively. Generally, the transactions will try to get exclusive locks when they want to do some write operation. Of course, even to read operation also we can request it. But in generally, to write some data item, people will ask exclusive lock. Here people in the sense transactions. The second one, shared lock. Whenever I want to read the data, then I need only shared lock. Why to lock the room? Why to lock the system, sir? I can read the data in the system. At the same time, other people also can read it. I don't have any issue, or I don't have any disturbance, because I am not the one who is modifying it. So many people can read the item at the same time. So that is the meaning of shared lock. So a data item can be locked in two ways. The first one is exclusive lock and the second one is shared lock. If you are getting any doubt at any point of time, please raise in chat box. Lock compatibility matrix. Whenever a transaction is having exclusive lock, what are the possible situations for other transactions? Similarly, whenever a transaction is having a shared lock, what are the possible scenarios for the other transactions? Let us discuss it. Represents the relationship between shared lock and exclusive lock of two or more transactions. Two or more transactions. What does it mean? Let us assume X is exclusive lock. And S is shared lock. So these are the notations we are following to represent the compatibility matrix. Okay. Now, a transaction may have two possibilities. Either it can have an exclusive lock or it can have a shared lock. Now the question is, suppose this is my T1. There is one more transaction which is trying to get the locks. He is trying exclusive lock. Now the question is, whenever first transaction is having exclusive lock on a particular data item, can you give the same exclusive lock to another transaction? No, sir. Until T1 completes its work, I should not allow or I should not give exclusive lock to any other transaction. So there is no possibility to get exclusive lock on the same data item. If T1 is already having exclusive lock, how can I allow other transactions if T1 not completes? So that is the story. Similarly, suppose T1 is reading the data. When someone is reading a document, how can I allow the second transaction to modify the document or to modify the data item? So whenever a transaction is having shared lock, then also if some other person wants exclusive lock, then compulsorily he need to wait, because the first person who entered already in the room, he need to leave it, right? So this is also not allowed. So when one transaction is working, either it is a read operation or write operation, if another transaction wants exclusive lock, you want exclusively for him, then compulsorily he need to wait until the first transaction releases the locks. Suppose the second transaction wants only shared lock. He don't want exclusive lock. He wants only shared lock, right? Then If the first transaction is writing or doing some modification on the data item, this person is not allowed to read the data. When one fellow is modifying the data, how the second fellow can read the data? So this is not possible. Now the last one. The first transaction is reading the data item. The second transaction also wants to read the same data item. When both persons are reading the item, what is the problem, sir? No issue, right? So two persons at the same time can watch the same video, can view the same details of some particular object. So this is allowed. Hope you understood the meaning of this compatibility matrix. So when one person is working, one candidate is working, the second candidate also can get it. The second candidate can also do work, but only when, sir? Only when both wants only shared lock, because they wants to read only the data item. This is the meaning of the lock compatibility matrix. So the same points are, any number of transactions can read at the same time. There is an object, not only 2, 3, 30 members, 100 members. Any number of transactions, sir, here members in the sense transactions. Any number of transactions can read the same data item. But whenever one fellow or one of the transactions wants to write it, no other is allowed to work on it. So even if one of them is going to write, so when one fellow among all the fellows wants to write or is writing, then no other transaction is allowed to access the item. That is the meaning of this lock compatibility matrix. Then suppose if I don't follow two-phase locking protocol, of course we have not discussed what is two-phase locking protocol. That means whenever we are having locks to the room, you may feel that again why we need to follow protocols. Sir, there is a lock mechanism. Simply we can follow lock mechanism. Why we need again some rules and regulations? Okay. If I don't follow any protocols, if I use only lock mechanism, that means whenever I need to work on a data item, I will get the lock and I will work. Once I complete, I will release it. Okay. If I follow this simple locking protocol, there are some problems. There is a chance of those problems. What are those problems? The first one, inconsistency. The second one, deadlock. The third one, no guarantee for serializable schedules. Sir, what is the main purpose of concurrency control protocols? It needs to produce only serializable schedules. But if I follow only simple locking protocol, there is a chance of producing non-serializable schedules, right? Similarly, there is a chance or there is a problem of inconsistency and there is a chance of deadlock also. Let me give examples for each of these problems. When we follow simple locking protocol, still there is a chance of having these three problems. Let me give one example for each of these problems. Coming to the first one, inconsistency. For example, suppose I have two transactions, T1, T2. Okay, let us assume T1 wants to transfer some 100 rupees from X to Y. Okay, and let us assume the initial values of X. No need to know the initial values, sir. To have better understanding, I am writing some initial values. Right? So let us assume these are the initial values. The first transaction, what it is supposed to do, sir? It's supposed to transfer 100 rupees from X to Y. The second one, its work is just it wants to display the total of two items. Display the total amount of X comma Y. So it wants to display X plus Y, right? So let me write the operations. Let me give one example of schedule which follows locks. T1, T2. Let us consider T1, sir. It wants to modify the value of X because it wants to subtract 100 rupees from X. So first it need to get exclusive lock. It's supposed to get exclusive lock. Let me write XL. Okay. My intention is exclusive lock. On which data items are? On small x. After getting exclusive lock, first it wants to read the value of X. Then it wants to write the value of X. What it will write, sir? X equal to X minus 100. Okay. This will update and it will return back to the database. Since it completed, it will release the lock. Okay. So this is my first operation, second operation, third operation, fourth one. Suppose now T2 started. So it want to display the value of X plus Y. So he wants to only read the values, right? He wants to read only the values. Of course, you can get exclusive lock also. Suppose he got scheduled lock of X and he read the item. Then he got scheduled lock of Y. Then he read the item. Let me write it here, sir. In the next step, it will display X plus Y because he knows both of the values. Then he will release the locks. Then my first transaction starts updating on Y. So he needs to get exclusive lock on Y. What he is supposed to do, sir? First he wants to read. Then he wants to write. In write operation, what he will do, sir? He will do Y equal to Y plus 100. Because the 100 which you subtracted from X, that we supposed to add here. Then he will release it. Clear, sir? Now look at this. He read the value. How much he read there? 1000 rupees. Then he return minus 100. So it will be 900. Then he got shared lock. What is the value of this one X, sir? 900. And what is the value of Y, sir? 2000. And you displayed 2900. Sir, suppose you are transferring from one of your accounts to another account. So both accounts are yours only. So when you verify the total balance, you got suddenly 2900. Either whatever the initial values may be, something like 1000 in X and 2000 in Y. So the total should be 3000. But suddenly I got, or it got displayed 2900. Where 100 has gone, sir? Right? So this is the problem of inconsistency. Only for our understanding purpose, we taken this account, sir, or money matter. Okay, there is a chance of inconsistency. That is my main intention. Here I followed locking protocols. My intention is simple locking. Whenever I want to access, I am requesting a lock and I am working and I am releasing it. Still, there is a problem of inconsistency. Why? Because, sir, whenever you transfer from one account to another account, the total should be remain same. But here something was displayed, which is not the original total sum. Hope you understood it. The next one, deadlock. Generally, what is deadlock, sir? This fellow is waiting for this fellow, and this fellow is waiting for this fellow. No one is making any moves. Okay, something like he is at one spot and he is at another spot. This fellow is waiting for other one to come to him. Okay, and this fellow is waiting for other one to come to him. No one is moving. When no one is moving, what will happen, sir? There is no progress. Everyone will wait for the lifetime. That is the general scenario. Here what will happen in the case of transactions? Let me give one example. Okay. Let me have only two transactions. No need of the inner details, sir. Suppose T1 wants to work on two data items x comma y. At the same time, T2 also wants to work on the data items y comma x. Sir, for better understanding, I written x comma y comma x. It doesn't matter, right? So now let me give a schedule. T1, T2. Look at this, sir. First, transaction 1 requesting lock for x. So it requests exclusive lock for x. Okay. And it is working. It is working. It not released anything, sir. Now, since y is free, T2 requested lock on y. He is also working. Okay. Now, look at this, sir. T1 needs lock for y, but it was already held by T2. Okay. Similarly, T2 needs lock for x. Can you grant this lock, sir? No, because that lock was held by T2 and he is not releasing because he not completed his work with x plus y or with both items. Both fellows are feeling that once I complete the entire work, I will release the lock. So he got the lock for x and doing some work. Then he wants to request for y, but he is not releasing x. If you don't release x, how T2 can complete? If T2 cannot release y, then how T1 will complete? So this one is waiting for this fellow. And this fellow is waiting for this fellow. So what will happen, sir? They will wait for each others for lifetime. So this is the concept of deadlock. Hope you understood it. Then the next one is, even we follow simple locking protocols, there is no guarantee that it will always produce serializable schedules. So let me give one small example which is not conflict serializable. Even I follow locking protocol, there is no rule that not conflict serializable schedules. Okay. Let me have a simple example. Suppose T1 wants to sir, T1 wants to do some transfer from X to Y, some 100 rupees. Similarly, T2 wants to transfer from Y to X, some 10 rupees or some any rupees, sir. My intention is both are having work with two variables X comma Y. Okay. Instead of having this 10 comma 100, simply you can write T1 wants to work with two variables X comma Y. T2 wants to work with Y comma X. Okay. Let me give the schedule. T1, T2. So first T1 will get exclusive lock for X. T1 will get exclusive lock for X and it is working on X. After completion, it will release. Okay. Now let us suppose T2 get lock from Y. Okay, and he is working. After release, he will get it. Then again, T1 will get lock for Y. He will do his work. After that, he will release it. Then T2. he will get lock for X. After some work, he will release it. Okay. This is following simple locking protocol. Now the question is it conflict serializable? Is it conflict serializable? To verify conflict serializable, what we supposed to do, sir? We need to draw the precedence graph. We need to draw the precedence graph. What is the precedence graph for this example, sir? We have two transactions, T1, T2. Right? What are the conflict operations? Can I have this conflict operation? Yes. So that means T1 should complete first, then followed by T2. Right? So it should be like this. Then is this conflict, sir? Yes. He is working. Something like, let me have the operations WX, WY, WY, WX. So since both are working on same data and both are write operations, there is a conflict. So T2 also I need to draw a line. So here I have a cycle. Since I have a cycle, it will not be conflict serializable. So even if I follow locks, there is no rule that it will always produce serializable schedules. So that's why this locking mechanism also needs to follow some protocols to ensure it always produce serializable schedules. Then what are those protocols? We have mainly two types of protocols. What are those protocols, sir? The first one, two-phase locking protocol. The second one, graph-based protocol. So that is also lock-based protocol only. But before going to apply locks, first of all, the data items will be arranged using a graph. So that's why it is called graph-based protocol. Okay. So now let us start two-phase locking protocol. Two-phase locking protocol. This protocol requires each transaction issue locks and unlock requests. So each transaction can request a lock and can unlock. That means can get a lock, can getting a lock, releasing a lock. That should be in two phases. What is two phases? Sir, something like in morning session, I can get all the locks, whatever I want. Okay. Once the morning section is over, in afternoon session, I should not request any lock. Okay. I can release my locks. I can release the first lock, then I can do some work again. I can release the lock for second data item. Like that I can release, but I should not request a new lock in afternoon session. So here, as human beings, we are already having very clear distinction between which is forenoon, which is afternoon. So in forenoon, you can request any number of locks. In afternoon, we can release any number of locks, but in forenoon, I should not release a lock. In afternoon, I should not request a lock. So here, don't release locks. In afternoon, don't request locks. In afternoon, don't request locks. Right, sir? Now the question is, what is forenoon, what is afternoon? We know what is forenoon and what is afternoon, sir. How can transactions are having this forenoon and afternoon? Instead of forenoon and afternoon, they given two technical terms. One is growing phase. In our case, it is forenoon. So he can get any number of locks and he can do work also, sir. At the same time, he can work on the data items and he can request any number of locks. Shrinking phase. Here, he can release the locks, but he should not request a lock. That is the meaning of growing phase and shrinking phase. then how to differentiate between these phases? There is no rule that up to 100 operations growing phase, the remaining are shrinking phase, or up to 50 operations growing phase and after that it is shrinking phase. It is not like that, sir. Okay, so I can request a lock on X and I can do some work. I can request a lock on Y and I can do some work. Like that I can request any number of locks. Okay, so the entire one is a growing phase. But once suppose I released the lock on Y, once you start releasing, shrinking phase started. So there is no separate growing phase and shrinking phase, sir. You can do the work and request any locks, but once you start releasing, you should not request. Hope you understood it. You can request any number of locks you can gain, but once you start releasing, you should not get anything else. So that is the meaning of it. So here you can do any number of times or any work, sir, no issue. But it is not allowed to have a lock like this. You need a lock on some W, then this is not allowed. Once you start releasing, you should not request a lock. That is the main one. So you can remember this point. Once transaction starts releasing a lock, what happens, sir? Once it starts, shrinking phase started. Shrinking phase starts. Since the shrinking phase starts, it should not request new lock. It should not request new locks. Hope you understood it. So what is growing phase, sir? You are earning, we are earning. But once you start spending, you should not earn. Okay. So let me have this one, sir. Transaction can obtain locks. Transaction can release locks. What are the variations of two-phase locking protocols? These are the variations, sir. Basic two-phase locking protocol, strict two-phase locking protocol, rigorous 2PL and conservative 2PL. Basic two-phase locking protocol means what we discussed just now. It will simply follow the growing phase and shrinking phase. Okay, and if I impose some more conditions or some extra conditions on these phases, then the other variations will come into the picture, like strict, rigorous, conservative. So let us discuss each of these protocols one by one. Coming to the first one, before going to first one, let me give some notes about two-phase locking protocol. Two-phase locking protocols gives always conflict serializable schedules. Sir, concurrency control protocols always gives serializable. That is sure. Now the question is it conflict serializable or is it view serializable? We are not sure. That may be view serializable also. That may not be conflict serializable. But if I follow two-phase locking protocol, it always produces conflict serializable schedules. And even I follow 2PL, there is a chance of deadlock. So even if you follow two-phase locking protocol, there is a possibility that the deadlock may occur. Even there is a possibility of cascading rollbacks. So even when you follow two-phase locking protocol, there is a possibility of cascading rollbacks. Then what is the one and only guaranteed advantage, sir? The guaranteed advantage is conflict serializable. So this is guaranteed. The remaining may or may not. The first one, basic two-phase locking protocol. In basic two-phase locking protocol, simply we follow the definitions or the concept of growing phase and shrinking phase. Okay, so there is no other restriction. Transactions will obtain locks in growing phase. Once it start releasing a lock, it will not request any other lock. Okay, so before going to that one, let me give it, sir. Suppose, okay, why to write a 2, sir? Let me have it 1. Suppose T1 wants to work on 3 data items, then he will get lock on X. Sir, that may be shared lock or that may be exclusive lock. Okay, my intention is getting a lock, then it will work on X, then it may get lock on Z, again it will work on it, then he will get the lock on Y, right? Then he is working. Suppose he started releasing lock on Z, then he will not request any other lock. He will not request any other lock. That is simply basic two-phase locking protocol. Hope you understood it. So there is no rule on the operations or on the working operations. Okay, the only rule is all the locking protocols must be in first group. All releasing protocols, all locking requests should be in the first group. All unlocking requests should be in the second group. That's it. Hope you understood it, right? So this is about basic two-phase locking protocol. Sir, let me give one example where we can have deadlock even if we follow this one. The same example you can consider, sir. Suppose I have 2 transactions, both wants to work on X comma Y. So this fellow is getting a lock and it is working on it. Okay, and after some time it wants to something like, suppose I have WX, and let's continue. Then suddenly this fellow got lock on Y and he is working on it. Then he is trying to request lock Y. Then after that he is supposed to release the lock X. Similarly, he is supposed to get lock X and after that he will get it. Now if you observe the first transaction, what happens, sir? Locking protocols are in first group, unlocking protocols are in the second protocol. So they are following two-phase locking protocol. Similarly here also, locking protocols are in growing phase and the remaining are in shrinking phase. So this fellow is following two-phase locking protocol, but still T1 is waiting for Y, T2 is waiting for X. So T1 is waiting for T2, T2 is waiting for T1. So there is a chance of deadlock. So like this we can discuss example for rollbacks also. Because of time constraint we are not discussing it, sir. So even if we follow basic two-phase locking protocol, there is a chance of deadlock as well as rollbacks. So cascading rollbacks may occur, deadlock may occur. So this is one such example for deadlock. Then what is strict two-phase locking protocol? Transactions don't release X locks till it commits. That means all exclusive locks should be released once it commits the transaction. That means suppose a transaction wants to work on X, work on Y, work on Z. Let me have this one. Okay, on X he wants to write, on Y he wants to read. let us assume the remaining operations are write operations. Then this transaction will request locks, lock X and work on it, lock Y and work on it, lock Z and work on it. Suppose you completed your work on X. You completed your work on X. Okay, let us assume I got the lock on Z also. Let me have it. So at this point of time, you completed your work on X. Then you can release it, right? So I can release the lock it. But I don't release it because I not completed all my work. So even I completed with X, I not completed my work because I have worked with 4 variables. I completed work with only 1 variable. Then why should I release lock, sir? I don't release. Okay, because on X it is having exclusive lock. It is a write operation, but it can release Y. It can release Y, and again it can continue the work. Okay, but after that it will go like X, W, so on, because all they must be in the second phase. Okay, so transactions don't release any X locks till it commits. Okay, if it is a shared lock, it can release, sir. It is a shared lock. So shared lock can be released even it not completes. Before commits. Hope you understood it. Now, whenever I follow strict, there is no chance of cascading rollbacks. There is no chance of cascading rollbacks. Deadlocks may occur. The same example what we discussed in the case of basic 2PL. The same example you can consider here also, sir. Okay, because it is following strict two-phase locking protocol. Okay, so deadlocks may be occur even if we follow strict two-phase locking protocol. What is strict, sir? Transactions don't release exclusive locks till it commits. Produces strict schedules. The next one, Regress two-phase locking protocol. What is Regress two-phase locking protocol, sir? He is somewhat something like middle class people, whether it is a shared or exclusive, whatever it may be. Something like I taken the same example, right? X, Y, Z, W. He needs to work on 4 fellows. This is right, and this is only read operation. This is right. This is right. So he started get the lock for X, get the lock for Y, get the lock for Z, get the lock for W. So he's doing. Now he is not allowed till he completes. He don't release anything. Even he completes with Y, he will keep it. Something like I entered in a room and there are 4 books. I completed 1 book reading, but I don't give key to any others. Okay, I will complete all the 4 books, then only I will go automate it. So only once I commit, then only I will release the locks, whatever the lock may be. Okay, that is the regress, whether it is shared lock or whatever it may be. Okay, it don't release any locks. That is regress two-phase locking protocol. Sir, please observe, once he got the lock for X, he is not waiting for lock for Y. Meanwhile, he is working. Meanwhile, he is working, sir. So even if you don't have locks for all items, you can start work, but you should not release any lock till you don't complete work with all items. Why I given this point is important for next variation. Okay. So here also no cascading rollbacks, sir. Sir, if strict 2PL is producing no rollbacks, how can regress, sir? He is not releasing only X locks. This fellow is not releasing any locks. So surely no rollbacks. But there is a chance of deadlock. There is a chance of deadlock. The same example you can trace out for these three types, sir. So that's why I given only one example for basic. The example which we discussed for basic, you can trace it for strict as well as regress also. Now conservative. He is very middle class person. So he don't start, or he is very afraid of having deadlocks. So what happens is transactions get all the locks before it starts. Transaction get all the locks before it starts. For example, the same example, let us consider T1 is having work on write, read, write, write. Suppose T1 started, he got the lock for X, then he don't start work. He should not do any work. Don't start working because you are not sure that whether you get the locks for other three items or not. If you don't get lock for other three items, then you should be in a waiting state. Then why to start and why to take risk? I will wait for 5 minutes. If I don't get locks for the three items, I will release it also. I don't start any my work. So I got lock for Y. Then also I don't start. I got lock for Z. I got three items, but one item is pending. Still also I don't start. Suppose I am not getting lock for W. I wait for some time. After my patience last, I will release everything and I will go back. Go back in the sense I will be rolled back. Okay. So till he gets all the locks, then start working because you got all locks. Got all locks. So start working. Start working. Then commit. Commit in the sense you completed entire work. Then release all locks. Okay. This is very safe side. Okay. Once we start work means we have all the locks with us. So no one can stop us. I will do my work slowly. After I commit, I will release everything. So this is my growing phase. Then this is working phase. Yeah, let me write this down. Growing phase. All locks. Then work. Then shrinking phase. Right. So if I follow this no cascading rollbacks, sir, of course, even the previous two also not producing any rollbacks. Here the advantage is no deadlock because I no need to wait for anyone because I have not started working, right? So I will wait for 1 or 2 minutes. If I don't get locks, I will stop the working, I will be rolled back. Starvation may occur. What is starvation? Suppose I am waiting for W, sir. I have all the locks for three items and I need only lock for W. Everyone is coming and working on W and going. Then every time getting lock for these three items. Since I am not getting for W, I may need to wait or I may need to roll back for so many number of times. I may need to wait for so many number of times. So that is starvation. Only one transaction is rolled back for so many number of times. There may be so many reasons, sir. Every time or so many number of times, only one transaction is going to be rolled back. That is the meaning of starvation. Okay. Let me write what is wait for graph. Sir, we have already discussed. Okay. Now for the sake of completion, here we are discussing. Okay. What is wait for graph? Let me write it. Suppose T1 is a transaction and it needs the lock for X. If it is free, T1 will get it. Suppose the same situation, T1 needs a lock for X. But this was already taken by some T4. Then what happens, sir? T1 need to wait for T4. T1 need to wait for T4. In such case, we write like this. Okay. T1 is waiting for T4. Or you can use like this also, sir. Once T4 completes, then only I can start for T1. Okay. To have symbolically, T1 is waiting for T4. Now let's come to this situation, sir. What is the first transaction, sir? Let me write here. L1 of A. What is the meaning of it? Okay. Let me write it here, sir. L1 of A. What it mean? Transaction 1. That is the meaning of 1. Needs lock on A. Transaction 1 needs lock on A. That is the meaning of it. Suppose they return U3 of A. T3 releases lock on A. Now let me draw the wait for graph. Totally how many transactions you are having, sir? I think there are 5 transactions. T1, T2, T3, T4. Let me have T5. Okay. Let me write all the operations first. The first one, L1 of A. Sir, till now, no one is having any lock. So it is granted because A is free. Okay. Better to write the items here, sir. A, B, C, D. Am I right? Yes, we are having only these items. Since A is free, I given lock to T1. So T1 is having lock A. Then T3 requesting for D. Is D free, sir? Yes. So you can give for 3. Yes. Then L1 is requesting for B. Can you give, sir? Yes, it is free. I given it. Something like assume there are rooms, sir. In a room, only one transaction is allowed. Now U1 of A, he releases it. Sir, he releases means there is no one. It is free. Then L2 of C. 2 needs C. C is free, sir. Yes. So up to here everything is fine. Then what about L2 of B? So 2 need B, sir. 2 need B, but B already held by T1. So please observe it. Held by T1. So T2 needs for T1. T2 needs for T1. So our T2 is waiting for T1. Then L1 of D. Is D free, sir? No. D is held by 3. So T1 need to wait for 3. T1 need to wait for 3. Then L2 of B. I think L2 of B we already have, sir. Okay. Anyway, it's a duplicate value. Leave it. So L3 of C. Is C free, sir? No. It was held by T2. So T3 need to wait for T2. Right? Then what is the next transaction, sir? Let me write it here. Sorry, sir. Okay. So L3 run, right? L4 of A. 4 need A. Is it free? Yes, free. So sanctioned. L4 of C. C free, sir? No. So it held by C held by T2. So 4 need to wait for T2. L5, acha, we have 5 transactions, fine. Is A free, sir? No. So it held by T4. So 5 need to wait for 4. 5 need to wait for 4. Right. That's it. Hope you understood it. Now this, if this weight graph is having cycles, if this weight graph is having cycles, then deadlock. Otherwise, no deadlock. Is there any cycle, sir? Yes. Cycle. So there is a chance of deadlock. That is the usage of wait for graph. Okay. Please go through it, and if you have any doubt, please raise in chat box. So it is not resulting in any deadlock. Now let's go to one more question. Which of the following are strict two-phase locking protocols? Sir, first of all, what is strict two-phase locking protocol? It don't release any exclusive locks. Before commits. Okay. Now let me write only the locks. Shared lock. Fine. Exclusive lock. Fine. Now you released it. It is a shared lock, right? I think you can release it. Since it is a shared lock, you can release it. Please observe it, sir. On A, you have shared lock. So can release. No issue. Then you released lock of B. So this is growing phase. This is shrinking phase. And you are releasing only shared lock. So no issue at all. It is strict. Now the question is, can I say it is regress, sir? Can I say it is regress? No, sir. Whether it is a shared or whatever it may be. Here you are doing some work, right? If you are having some pending work, you are not supposed to release any lock. Please observe it. Between these two releases, there is some work. So it is not regress. Okay, but it is strict. What about here, sir? Shared lock, exclusive lock. This is work, sir. Work completed. So he is releasing both locks. So he released A, he released B. So till he commits, he is not releasing anything. Till he commits, he is not releasing anything. Okay, when he is not releasing anything, automatically he will not releasing any exclusive locks. So it is both strict and rigorous. Hope you understood it. Please check it. Can you say what about conservative, sir? Can I say the first one is conservative? No, sir. Please observe it. Lock. Lock. Before you get lock, you started work. Can you start work before getting all locks? No, sir. It is not conservative. What about here, sir? You got lock and you started work. Before you get all locks, you should not work. So this is also not conservative. Hope you understood how to verify the variations of two-phase locking protocols. Is that clear, sir? Yeah. Let us do one more question, sir. Which of the following transactions follow two-phase locking protocols? Okay. Here they are using some notation, sir. Let me give it. Lock, suppose they written like this. Lock 4 of x. What does it mean? Transaction 4 needs lock on x. Suppose they written unlock 3 of x. That means transaction 3 releasing lock on x. Now we need to verify only two-phase locking protocols are. So just we need to verify whether they are following growing phase and shrinking phase. Whenever I want to say schedule is following 2PL, this is the main important point, sir. Schedule following 2PL. We can say it, but when, sir, if all transactions follow 2PL, even one transaction failed 2PL, the entire schedule is not following 2PL. So we need to verify the schedule. For that we need to verify each and every transaction separately. So let us do these three schedules. I think they given three schedules, sir. Schedule 1, schedule 2, schedule 3. Let us verify each of these one by one. Coming to the first one. Sir, what is the first one, sir? Lock 1 of A. So it is related with transaction 1. Fine. He is getting lock on A. Okay. Instead of this one, can I write simply lock of A? So we completed the first one. What about second one, sir? Read 1 of A. 1, first transaction, reading A. What is the next operation, sir? Lock 2 of B. Second transaction. So start it. So he got the lock for B. Then what is the next operation, sir? Write 2 of B. Second transaction is writing B. Hope you are understanding or following the notations. Lock on A, read on A, write on A. Then write also we completed. Then lock 1 of C. So 1 is fine. So he is requesting lock on C. It's also fine. Then unlock 2 of B. So 2 releasing B. 2 releasing B. Let me write like this. Unlock. Fine. Unlock 2 we done, sir. Let me write it here. Unlock 1 of C. So 1 releasing C. 1 releasing C. Then lock 2 of C. 2 need lock for C. Need lock for C. Then unlock 1 of A. 1 releasing A. 1 releasing A. Now the question is, which is growing phase, which is shrinking phase? Sir, lock. Yes. This is very clearly growing phase because no unlocks. Now I have unlocks. Shrinking phase. So this is following 2PL. What about second one? Lock lock. We stopped it because you started unlocks. So this is growing phase. If I assume it in shrinking phase, how can I have this, sir? Once you start releasing, you should not request locks. Since T2 has failed 2PL, the schedule is not following 2PL. Hope you understood it. Let us do the second schedule. What is the first operation, sir? Lock 1 of A. So T1 need lock on A. Fine. Then the second operation is lock 1 of B. 1 need lock on B. Fine. Then unlock 1. Of course, this is also about 1 only. So 1 only releasing A. Then lock 2 of A. So now I got transaction 2. So let us start T2. He need lock on A. Then write 2 of A. So 2 is writing A. Yes, 2 is writing A. Fine. Then unlock 2 of A. So 2 is releasing. 2 is releasing A. Then unlock 1 of B. 1 releasing B. 1 releasing B. Yeah. Now what are the growing phases or shrinking phases, sir? Lock, 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 lock. Yes, fine. So if I assume this is growing phase, then it should be shrinking phase. No issue. Growing phase is having only request for locks. Shrinking phase is having only releasing locks. Here, this is growing phase. Once he start releasing, that is shrinking phase. Yes, fine. So both are following two-phase locking protocols. The first transaction following 2PL, the second transaction following 2PL. So that's why this schedule S2 follows 2PL. Hope you understood it. Even if one transaction failed in 2PL, the entire schedule is not following 2PL. Is that clear, sir? Let us do the third schedule. The same procedure you can follow, sir. The first operation lock 1 of A. So transaction 1, it is requesting A. Then lock 2 of B. So I need second transaction and it is requesting B. Then lock 1 of C. 1 only, sir. So he need lock on C. Then lock 3 of D. So we have third transaction also. Let me write it. Third transaction. Lock D. Then unlocks, right? Yeah. Unlock 2 of B. 2 is releasing B. Fine. Then lock 3 of B. 3 need B. 3 need B. So lock 3 also done, sir. Then unlock 1 of A. So 1 releasing A. Then unlock 3 of D. 3 releasing D, sir. 3 releasing D. Fine. Then unlock 1 of C. 1 releasing C. 1 releasing C. Fine. Then the last one is lock 3 of C. 3 request C. 3 request C. Fine. Now let us verify. This one, fine. Locks followed by unlocks. So this is 2PL. I have only one lock, that is growing phase. I have only one unlock, it is sinking phase. This is also no issue. What about here, sir? Locks, you done it. Then what about here, sir? Once you start unlocking, this is not allowed. So the transaction 3 is not following this one. So schedule 3 2PL has failed. Schedule 2 you verified, it is following 2PL. Schedule 1 it is not following 2PL. So only the second schedule is following 2PL. Hope you understood it. So this is the way how we can verify two-phase locking protocols. In next session we continue graph based protocols followed by timestamp based protocols. Thank you.